You'll be happy to know that you're done with radicals probably forever for most of you. So that last section will be the last of it. We don't do anything with that in grade 12. Okay, so today we are looking at polynomial expressions. And the first thing that we look at in a polynomial expression is the non-permissible values. Okay? So we did have a little bit of that in the last section, except the non-permissible values were found underneath the square root. The non-permissible values now will be on the bottom of a fraction. Okay, so the first thing that you do when you reduce a polynomial expression, and I call it an expression, not an equation. Okay, this is, again, this was done, you guys did this on your test. Hurry up.
Sorry.
You did this on your test, and quite a few of you solved for it. When there is no equal sign, you are not expected to find a value for x. When there's no equal sign, all you're doing is reducing. So, some circumstances, it's factoring. Some circumstances, it's just reducing a fraction. You are not expected to find an actual value when there's no equal sign. So for this, if I wanted to reduce this, let's say, okay, the first thing I do is I work with my non-permissible value. So I do that by going 2x minus 4 can't equal 0. I can't have a 0 on the bottom of a fraction. So for what value is that? 2x can't equal 4, x cannot equal 2. So there's my non-permissible value. At that point, you might be asked to reduce this. Well, there's nothing on top and bottom that can cancel out. You could simplify it and make it this, but I wouldn't ask you to do that. But at some point, you may have to. Okay? So the first thing that we're focused on is your non-permissible values. You cannot have 0 on the bottom of a fraction. So then I'm trying to find out what value of x would give me a 0 on the bottom. Okay, so if you look in your book, again, you can follow through in your book if you need to. Write this out as you go. So the first one in your book is 1 over 2x minus 3. So the non-permissible value is 2x minus 3 can't equal 0. And you solve for x. Add 3. Divide by 2. So the non-permissible value here is 3 over 2. Okay, so you can follow through in your book. Okay, so now, what we are attempting to do, and the reason that we do this is we are going to attempt to draw these, not necessarily in grade 11, but more in grade 12. We're attempting to draw polynomial functions. But when they're written in certain forms, they're difficult to do. For this guy, I could, in grade 12, what you would learn is you would graph this as a quadratic. You'd find your zeros, find your vertex, and then you'd take 1 over all your y values. There's a process to this. What we need to be able to do is, can we reduce this? Can we make it something more manageable for us to graph? Right now, I'm not asking you to graph this. All I'm just saying is, what are my non-permissible values? So on the bottom, I have x squared minus 5x add 6 can't equal 0. So what do you propose we do now? Factor it. Because we have a quadratic, we want to be able to factor it. If you cannot factor, you just leave it. If you cannot factor it, you just leave it. This has to be factorable as you go through all of these. Yes, Rex?
So with this, you'll never have to use including the square
No.
underneath and all?
No. It's just pure factoring. All of this is factor, factor, factor. So all this unit is going to be based on your ability to factor. Okay, so factors of x squared, factors of 6 that give you -5. Perfect. What can x not equal? 2 and 3. Okay? What's the problem?
Well, I just feel like don't understand why you do now.
Because if I put a 2 in here, I'll show you 2 reasons why. If I put a 2 in here, I get 2 squared minus 5 times 2 adds 6. What's 2 squared?
4.
4 subtract 10 is what?
-6.
Negative 6 plus 6 is what?
0.
Is that a possible value?
No.
No, you can't have a 0 on the bottom of the fraction. So what I'm doing is I'm trying to find out what values of these, what values do I substitute in for x that would give me a 0 on the bottom,
Oh.
because they're not permissible. So if I were to solve an equation, I can't get this as part of my answer.
Okay, so it's
Okay.
almost like the restriction of it.
It's exactly the same.
Okay.
Yes. Now, I'm going to show you a second reason. I'm glad you asked, but I'm going to show you a second reason. If I were to graph this, do not write this down. You don't have to do this. You will next year, but not this year. My roots for this equation, y equals x squared minus 5x plus 6, are 3 and 2. So I go 0, 1, 2, 3. So my roots are this. My graph would look something like this. That's what my graph would look like. Okay, so that's the equation. That is the graph of y equals x squared minus 5x add 6. Okay? I don't know what the vertex is. I can solve for the vertex. I put 2.5 in, solve. Doesn't matter. The point is, I see what's happening here. Now, that wasn't the equation, the expression that was given to us. The expression that was given to us was y equals 1 over that. Like that. Okay? Again, I am taking you to a grade 12 level. You do not need to do this. So what am I showing you? The other reason why I can't have 2 and 3 as part of my answer. When I take 1 over this graph, I'm taking 1 over all my y values. What's my y value right here and right here?
2 and 3.
0.
Oh, 0.
So when I take 1 over 0, what do I get? No, I don't.
It's just error.
It says an error, but what does it actually mean? What do we call that?
Not.
Undefined. Thank goodness we got the grade 10 in here again. So that means that I have asymptotes right here. So I stick them in there. So what I'm saying is, this graph here, if you were to graph it on your calculator, there wouldn't be values here. They'd give you what we call asymptotes. And then this graph would look like this, this down here, and like this. That's what this graph, 1 over x squared minus 5x plus 6 would look like if you were to put it on a calculator. Okay? I'm not asking you to do that. What I'm showing you is the reason that 2 and 3 are not acceptable values. Because if I go 1 over those values, when I put into here, I'm going to get 0, an undefined value. Okay, so that's the second reason why I can't end up with this, undefined. Okay, so my non-permissibles are what values are going to make that undefined. What values would make that equal to 0? Okay, C now. Right here. X squared minus 9x add 14.
Over 2 squared minus over x squared minus 25.
Minus what?
25.
Thank you. Okay, this is an expression. This expression is a fraction. What do we do with fractions? Say that again? I simplify. I need to simplify my fraction. So what I'm trying to do here is I want to first of all find out what my non-permissibles are, and then what I'm going to do is I'm going to simplify it, because this is not a simplified fraction. So the first thing I'm going to do is work with x squared minus 25. It cannot equal 0. Okay? Excuse me. X squared can equal 25. X cannot equal plus minus 5. X cannot equal plus 5. X cannot equal negative 5. Negative 5 squared is
25.
25. 25 subtract 25 would give me 0 down here. Plus 5 squared is 25. 25 subtract 25 gives me 0. So I cannot have my answer, my final expression, equal to 5 or negative 5. So what do I do now? I want to simplify this. So what's the first thing I got to do in order to simplify it? Any ideas?
Multiply the bottom by the x minus 25 by the top.
No.
X squared plus
Oh, okay. You guys, I understand where you guys are. What you're both saying the same thing. When we did radicals, we multiplied by the conjugate on the bottom. That's not what I want to do. Okay? I have a fraction here. Let me try it like this. Okay? Reduce that for me. It reduces to 2/3. Okay? So, why does it reduce to 2/3? Well, 4 is 2 times 2, agreed? Okay? And 6 is 2 times 3, right? When I take 2 divided by 2, what do I get? 1. So I reduced it to 2/3. Follow? So what do you suppose I do here then?
You want to go check square?
No, can't. Because of the adds and subtracts.
Figure out the greatest common factor.
You're getting closer. Use the right word, but not the greatest common. Okay? How do I simplify a quadratic equation? If I ask you to simplify it, what do? What do? Factor it. That's right. So let's factor it. On top, what do I have? X and X. Factors of 14 that give me 9. Negative 7, negative 2. This is not going to work out the way I want it, but whatever. Make sure I got it written right. Okay? And on the bottom, what is x squared minus 25? When I factor it, what do I get? That's right. Very good. I get that. Okay? Why? Difference of squares. Perfect square subtract perfect square. You have to recognize that at all costs. You must see that. Okay? So now, at this point,
Mr. Wilson, to the office for a phone call, please. Mr. Wilson.
at this instant right here, if there was anything that was the same on top and on the bottom, I would cancel them. But it's not, so my final answer is this, comma, that. That's my final answer for reducing this expression. I have factored it to its fullest. There's nothing to cancel out. I leave that, and then I write in my restriction beside it with a comma. Make a note of that in your book. Alright. Everybody got that down? Yeah? Okay. So first order of business, work with your restrictions. X squared plus 3x add 2, can it equal 0? Is that factorable? Are there factors of 2 that add to give me 3?
Yeah.
Yeah? Okay. So 2 sets of brackets. Very good. X plus 2, x plus 1. X cannot equal negative 2 or negative 1. Okay? So now that I've done my restrictions, what's the next step? I have to simplify my fraction, so what do I do to simplify? Factor. What is the top one factor to?
X
Nothing.
plus 1, X minus 1.
Great. X plus 1, X minus 1. And the bottom, we factored already to X plus 2, X plus 1. Just like that. Okay, so I factored the top, I factored the bottom. The beauty of this, we've already factored the bottom always. So all I have to do is just rewrite it. Okay? Now I have a fraction. Is there something common on top and the bottom that I can cancel? X plus 1, X plus 1. Just like that.
We're a roll of Scotch tape. You have?
I thought so. I thought I had, yeah, it's right here.
Oh, okay, thanks.
Okay? So my final expression is written as x minus 1 over x plus 2, comma, x can equal negative 2 or negative 1. One of the things that you have to remember is to always do this first. Because if I don't do that, and I did it at this point right here, I wouldn't have both values that it couldn't equal. Yes, Brent?
What would happen if, say, the top of that wasn't factorable? Then how would you write it?
Just leave it as is.
So then you drop it to the bottom, and like say, x would be x plus 2 bracket x plus 1.
No, you just leave it. Whatever you had on top here stays on top. You don't move them up and down.
Right. And then you just divide that by the bottom.
If it's possible. It's got to be, but if you look here, x plus 1 is in brackets here. They're exactly the same. I cannot. I need everybody to watch. Put your pens down and watch, because this gets done all the time. This is not allowed. Do not do that. Okay? Because of the adds and the subtracts, you cannot cancel like this. The only way you can cancel x squared with x squared is if you're dividing only x squared by x squared. This does not work. Do not do that. Bad. Alright. So go back. X squared minus 1, x squared plus 6. Okay? Alright, so all we're doing is factoring. This whole day, you're just working on your factoring skills and reducing expressions. They're going to get a little more complicated because we're going to get into multiplying and dividing, but it's still factoring. Okay? Let's look at the third one. In that one? Yes.
Minus 4 over 4x squared minus 1.
Okay, so first things first, what are we doing?
Restrictions.
Restrictions. So 4x squared minus 20 can equal 0, right? What do I do? Good job. Okay? So x can equal the square root of 5.
But it's
Or negative 5.
It's like 4x squared minus 20x.
Is there 20x on the
Yeah,
bottom?
it's not 4x squared minus 20.
Oh. Do you have a 20x in yours?
Yeah.
Yeah?
Yeah.
Okay. Some of these books have only 20, and some have 20x.
Over here, it has 20x. Or
No, that's okay.
look at the page. It says 20x.
That's 20x? Okay. So that changes things then. So let's go back and do this again. So somebody have a misprint in that?
No, no. Are you on page 8?
I'm on page 232.
Yeah, we're on page 231.
Yeah.
That's why.
Oh, who cares? We're gonna figure both out anyways.
But it's the solution for this one. So.
Excuse me for the interruption, Colton Waller to the office, Colton Waller.
Okay, so let's go back to this guy again. All right, at this point, okay? what do I do with this? I have a binomial now. What's the very first thing you were ever taught to do when it came to factoring? Greatest common factor. So let's look. Is there a greatest common factor between 4x squared and 20x? 4x. So let's factor that out first. What does that leave me with? X minus 5 can equal 0. Okay? So therefore, 4x can't equal 0. That means x can't equal 0, and x can't equal 5. Alright? If this is 0, 0 times 4 is 0, 0 times anything there is 0. So x can't equal 0. If I put a 5 in here, 5 subtract 5 is 0. 0 times 4x is still 0. Okay? So my restrictions are those. So now, we need to reduce my fraction. What's the first thing I want to do here? Factor. And the first thing when I factor is look for what? Is there a greatest common factor on top? 2x. So that leaves me with x squared minus 2x minus 15. The bottom we already factored, didn't we? What did we get? 4x, which leaves me with x minus 5. Okay? I can cancel right now. I'm able to cancel this right now. Okay, but I still have this squared function here, so I want to factor it one more time if I can. So, can I factor it? X squared minus 2x minus 15. Factors of negative 15 that I have to give me negative 2. X minus 5. X add 3. Excellent. 4x. X minus 5. Okay, so I've got everything simplified as far as I can. Now I just cancel out. That cancels. X divided by x. That cancels. 2 divided by 4 is, I'm not using decimals, is 1 over 2. Okay? So 2 divided by 4 gives me 2 on the bottom. X divided by x cancels. X minus 5 times x minus 5 cancels. So what am I left with? X plus 3 over 2. My restrictions being 0 and 5. Factor, 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 factor. And then simplify. It's really not terribly difficult. Unless you can't factor. Unless we have trouble with our times table. Not naming names. Am I? Okay? Alright. Any questions about this so far? Because I'm going to take it to the next step, which is just multiplying and dividing, which is still the same stuff. But I just want you, any concerns about factoring? So greatest common factor, factor, and then simplify after that. Go ahead.
When you divided the 2x by the 4x, then you just say...
X divided by x is 1.
Right.
2 divides into 4 twice.
Okay.
So it's like 2 over 4 is what? 1/2. So that's about 1/2 times x plus 3.
Yeah, I was just trying to give you like 2 divided by 4 is 1/2, but that's just 2 1/2 of 2.
It is 1/2. There's the 1.
Oh, yeah. I just listened to
Yeah. Okay? All right.
X is equal to 0.
Just one quick one. Let's have a look at this guy. Okay, so first things first is my restriction. 9 minus x can equal 0. 9, x can equal 9, right? So far so good? Yeah? Okay, let's factor the top part. What does it factor to?
X minus minus 9, x plus 9.
X minus 9, x plus 9 over 9 minus x. Okay, can I simplify this now? No? How come? Right. Is there a way I can make it so that's the same and then I can cancel? Not multiply. Yeah, how? I gotta do one thing. You're on the right track.
You have to put,
Okay, I want just a second, Brandon.
Well, if you divide it by a negative 1, you
But I'm not dividing because I'm having an expression here, so, no,
Conjugate?
no, you're on the right track, you just used the wrong terminology. Okay, so you're right. It's take a negative 1 out, but how? I'm gonna factor it. Okay, so I'm gonna factor a negative 1 out of the bottom here. So that leaves me with this. If I take a negative 1 out of both, that's essentially what you were telling me to do. Okay? Is take a negative 1 out of both of them. Now can I cancel? What am I left with? Yeah, or a negative 1 times x plus 9. That works too. Doesn't matter if the negative's on the top or bottom, as long as it's only on one. And then x can't equal 9. So this happens a lot. If your terms are reversed, so x subtract 9, 9 minus x, factor out a negative value. Factor out a negative value and then you can cancel them. Okay? Alright. I'm going right to the meat and potatoes of this, to the hardest part of this. Okay. Page 243. Question, working example 3C. Okay, so I'm still going to do the same thing that I have always done. The first thing is find my restrictions. Okay, so I'm going to focus on this fraction for right now. What part of this fraction cannot equal 0?
The bottom.
The bottom. So x plus 4 can't equal 0, right?
Yeah.
Therefore, x cannot equal negative 4. We okay? All right. If I'm focused on this fraction, what part of it cannot equal 0?
X squared minus x minus.
That's the most obvious one, right? What happens when I divide by fractions?
You can,
Sit? Yeah, exactly. So I have to flip this guy, right? So realistically, this is the bottom of the fraction right now, but when I reciprocate it, that becomes the bottom of the fraction. So I have to look at both of those values and find out the restrictions. So on this guy, x squared minus x minus 20 can't equal 0. X minus 5, x add 4 can't equal 0. Right? X can't equal 5 and negative 4. Well, we've already got negative 4, right? So we already know that. Now I got to look at the top part here and do the same thing. X squared minus 2x minus 15 can't equal 0. X minus 5, x add 3 can't equal 0. X can't equal 5 and negative 3. So again, I'm doing this fast. I'm going to leave this on the board for you. So I just want you to watch for right now, okay? And I'll give you a minute after to do this, because I don't want you to miss what we're doing here. So what did I do? I took this right here, can equal 0. I took that right there, can equal 0. Okay, so now I'm going to simplify, which I've already factored, so that's the beauty of this. I've already done the factoring part. I'm going to rewrite it, and then I'm going to cancel. So here's what I have. X minus 7, x plus 4, times. That's a 5. Yeah, thanks. Times. That goes on top, right? So what was x squared minus x minus 20? That there. X minus 5, x plus 4. And on the bottom, I have that guy, x minus 5, x plus 3. Okay? So I've already factored these two guys. Now I'm just flipping them, top and bottom. And now I can cancel. Because it's multiplying, anything on top that's the same as something on the bottom, I can cancel. X plus 4, x plus 4. X minus 5, x minus 5. What am I left with? X minus 7, x plus 3. And my restrictions are x can't equal
7 and -3.
-3, -4, and 5. Okay? -4, 5, -3. And there's my solution. That's a reduced expression. Okay? All you're asked to do in, what is this, chapter 6? 6.1 and 6.2 is work on your ability to reduce expressions. Eventually we're working our way up to solving questions. But for right now we're just looking to reduce. Alright? You want to see one more of these? Okay, I'll leave that there. Give you a second, I'll write the next one out. The difficult part will be the next section on 6.3 when you have to actually add these together, add fractions together. So. Sorry? 56. This is not the exact same question that's in your book. I've switched the question. There is one, but it's a misprint in the book, so I'm making it right so that it works for what we need. No, there's lots of mistakes in there. Okay. So, what's the first thing that we do?
Find your restrictions.
Find our restrictions. So, I've got x squared minus 15x plus 56 can't equal 0. What does that factor to? What are the factors of 56? Minus 8, minus 7. Awesome. So x can't equal 8 or 7. Good. looking at the second fraction, I have to use both of them. So x minus 7 can't equal 0, x can't equal 7. I've already got that one. And when I look at the top, 3x plus 6 can't equal 0, x can't equal negative 2. So there's my 2. Now right now, the restrictions are irrelevant, like they don't mean anything to the question. You're just finding them. But when you actually start solving these questions, then the restrictions mean something. When your answer comes up, you have to check and make sure it's not a part of your restrictions. But for right now, this is just practice. Doing this is just practice for what you need. Okay? All right. So, let's work through this now. Factor the top part out. What does it factor to?
X plus 4, x plus 4. Oh, no.
X
X
plus
minus
6.
Plus 6, x plus 2.
Yeah,
X plus 6, x plus 2. The bottom we decided was x minus 8, x minus 7, right? Times x minus 7 on top over here. And then what do I factor out of 3x plus 6? Factor out of 3. Leaves me with x plus 2. Okay?
Can you not just get rid of the 3 altogether? Since
No.
you factored
You can only get rid of the 3 altogether if you have an equal sign and a 0 on the other side. If you're doing expressions, everything has to stay, unless you're dividing it out, top and bottom. Okay? All right. Now I cancel. What am I left with? X plus 6 over 3, x minus 8. My restrictions are x can't equal
8, 7, negative 2.
8, 7, and negative 2. Yes, Rex?
Do you ever want us to distribute the 3 through
No.
brackets?
The whole point is to reduce, reduce, reduce.
Okay,
So once you've got it factored out,
just keep it.
just keep it factored out.
Okay.
Yeah. Yes, Brendan?
So you're gonna check your answer list or not
Not yet. When we do graphing,
really? When you solve for x, you do.
or solve for x, yeah, yes. Or you could graph. You could graph all of this and graph this, and it should give you the exact same graph. Okay? But we're not, no. Not yet. All right? Questions about it? You're going to like this a lot more than the radical section for sure. I guarantee you that. Those of you that factor well are going to ace this. It's all about factoring and reducing. There's not much else to it, especially in 6.1 and 6.2. Anybody have any questions about it? Yeah, go ahead.
You can't factor that, you have to do it the long way, like you have to do, you know, like you do the long way of factoring, you have to do the sum of that.
Yeah, it's possible.
You have to do it that way.
You may have to, yeah. I don't see it, but it is possible. So Brennan's question is this: what if I have the following? Six is 18, 92. Okay. So Brennan's question is this: what happens if I can't factor out a greatest common factor? Am I going to have to do this? Yes. You can factor though, but you can't take out a greatest common factor. So how do we do this? 3 times 6, 18, sum, 11, factors, 9 and 2. So you'd have 3x squared plus 9x, add 2x, add 6. Then put your 2 sets of brackets. Greatest common factor. 1x. Take greatest common factor out and greatest common factor a second time. What are you left with? So that is possible. You may get that situation. Okay? So we do need to know that. Alright? Okay. So, like I said, I'm away Monday, Tuesday. I expect you to have finished to the end of 6-2 for Wednesday. Yeah.
Brittany and I might not be, officially will be in Thursday.
Okay, anything else? Yes, Eli?
On your 2 bracket x plus 3
Yes.
bracket, how did you get 3x plus 2?
3x here?
No, right on the bottom right. How did you get that?
Okay, so this is what's common between this term and this term?
3.
No. What does this have and this have that are exactly the same?
X.
Look at the brackets, dude.
Same thing.
Yeah?
X plus 3.
So I take that from this one and take that from this one. So move it out. What am I left with here? 3x. What am I left with here? 2.
Okay.
You don't follow that? Okay, every time I factor, I want 2 sets of brackets like this, right? So the first set of brackets is whatever I factor out of here. What did I factor out of these 2 that are exactly the same?
X plus 3.
So I factored that out. I divided it out of here. When I divide this whole thing by x plus 3, what am I left with?
3x.
And when I divide this whole thing by x plus 3, what am I left with?
2. Okay, I see. Thank you.
Yeah, no problem. Okay? Alright, so we will need that. Okay? Alright, you've got till the end of Tuesday's class to finish all of this up.